Okay, hi again, guys. So this is our second module for electrochemistry. So I'm gonna discuss how to balance redox reactions. So in the last module, there was an introduction to what redox is and the difference between oxidation and reduction. So how important are they? Well, they're very important. The knowledge of each would help you in properly balancing the reactions. So definitely in one reaction, one is being oxidized and the other one is being reduced. The focus for this module will be how do you balance the reaction. So um, I'll be doing one which is neutral, and then I'll be doing another one which is acidic. And then for the third, which is for the basic, which basically has the same steps on how to balance it, I'll leave that up to you. But of course, again, this video is not limited to the video alone. Your questions can be answered during our sync classes, and of course, your discussion board, messenger chat, and FB group. Okay, so let's start. Basically, when you're balancing redox reactions, there are two methods. There are two popular methods. And the first one is the half reaction method, and the other one will be the oxidation numbers method. Personally, I've tried both methods, and um, it's easier. The half reaction method is actually the easier approach because in the half reaction method, all you have to do is understand the two half reactions in that reaction, and then of course analyze both reactions and then balance it. For the oxidation numbers method, it's also a very helpful method, and it actually removes the limits to the half reaction methods, because sometimes the half reaction methods can only be done, of course, two at a time, two reactions at a time. The oxidation numbers method would actually address that, wherein all you have to do is analyze the whole reaction and then get the oxidation numbers and then do the different steps into balancing it. But for this video, of course, I will just isolate it to half reaction method. I will create another video for oxidation numbers method as an extra to our module. Okay, so I've said the half reaction method is actually a series of steps that you need to do. So in this method, the two have the equation, the whole reaction is actually separated into two half equations or two half actions. One is for oxidation and the other one for reduction. Okay. So what are the steps? Okay, the first step. Okay, each equation is balanced by adjusting the coefficients that will be there up, 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 up. Okay, and adding water, hydrogen, and electron in this order. Okay, this is quite simple to follow. First, inspect your equation, get the two half reactions. By the way, for those wondering why I have like a half glove, I'm using it for my tablet, for the graphing drawing tablet, because you might be wondering why do I have this glove? Because thank you to one of you guys who suggested it. It's actually very useful. So going back, sorry, going back, uh, all you have to do is to follow the steps. Just follow the steps, and then it's actually fail proof. If you follow the steps are very simple. Only the order of what you need to analyze. Okay, first, I said separate the whole equation into two half reactions. The second one would be balance first the elements. Which elements? The non-oxygen and the non-hydrogen elements. These are the elements which of course are the main uh, compounds or elements in that reaction. Then afterwards, after balancing the non-oxygen and the non-hydrogen elements, look for the oxygen. If there are oxygen elements already in the reaction, balance those. And then if they're not balanced, you have to add water. So in oxygen deficiency, or you need to balance oxygen in the reaction, use water. Okay, let's write that. Okay, here you go. First, the non-oxygen and hydrogen elements. The second one be in this order. That's one, two, and three. Okay, these are how you're supposed to analyze it. Okay, so in that order. So when there's a deficiency or when you need to balance oxygen, you have to use water. That's where you get your oxygen. For hydrogen, it's different. When there's a deficiency or when you need to balance hydrogen atoms in the equation or the reaction, you have to use hydrogen. And they are getting positive. Water is neutral, hydrogen is positive. So it says there on the third step, I actually went ahead. Balance the hydrogen atoms, including those added in step two. Of course, you can see from the water molecule, there's actually of course, that's H2O. There's hydrogen there. You have to balance this. So even if you have used water, and of course there's hydrogen in water, you have to repeatedly add or add the needed hydrogen atoms to balance the hydrogen atoms in the reaction by adding each positive ions to the opposite side of the equation. And then let's move further to the steps. Add up the charges on each side. So let's go back. Let's go back. First, do the half reactions. Second, um, balance the non-oxygen and the non-hydrogen elements. The third, balance oxygen. If there should be deficiency, what do? You add water. Balance the hydrogen. And then if there should be deficiency, you have to add hydrogen ions. And then next would be adding up the charges on each side. You make them equal by adding enough electrons to the more positive side. Okay, and then it says here rule of thumb. Yes, we already saw this in the previous module. E, negative, and H are almost always on the same side. Yes, okay, that's most of the time correct. The E negative and the positive hydrogen ions are always on the same side. And then the next step, the electrons on each side must be made equal. If they are not equal, they must be multiplied by the appropriate integers. Of course, use the lower. As much as you can, use the lowest common multiple to be made the same. And afterwards, add them together. Common, common terms should be cancelled out. And then there are, of course, some notations or some reminders. If the equation is being balanced in a basic solution through the addition of one or more step, the appropriate number of OH must be added to turn the remaining hydrogen ions into water molecules. Eventually, if the solution or the reaction or the equation is a basic equation, uh, there's always an extra step because it's supposed to be the last step would be to balance it out, cancel which needs to be canceled, add the two reactions already to come up with one. Maybe right now you cannot visualize what I'm saying. I have two examples after this slide. Okay, but if it's a basic equation, there should be an extra step where you have to add extra OH ions to turn the remaining H positive ions into water. And then the equation can now be checked to make sure that it is balanced. So what do you check? What I need you to check would be, of course, the number of elements should be balanced, non-hydrogen, non-oxygen, oxygen, hydrogen, charge. Those should be checked. Okay, let's start one example. First one will be a neutral solution. So, of course, well, let me see, control. I go back first. Let me see. Let's keep my notations. Oops, why am I doing that? Let's discard my notations here. So let's just add, sorry, what did I do? I should not have done that. Oops, sorry. I think instead of inserting a new slide, okay, let's do a general slide so that the space is bigger. Okay, this is our equation. Okay, our equation is Well, that's copper plus iron is equal to, that's still iron, but in ferric mode, well, plus copper. Okay. You might be wondering what the AQs are. So it only means AQ stands for aqueous. Aqueous. Is that correct? Okay. Aqueous. Aqueous. And then for S, it means it's a solid. So here, aqueous meaning it's not liquid form. Well, let's search, let's be more specific what aqueous is. Let me just Google that. So you'll get the specific term. It says it contains water or it's a solvent. It's not pure liquid, but it contains water and probably another chemical, or in this case, copper, plus water. It is a solution. I'm just looking for my eraser. That's poorly written. So let's see. That's my pointer. So it says here that's A Q. And I think I got that wrong a while ago. It's Aquarius. There you go. Aqueous. Okay. So when it's an aqueous solution, sorry, when the element or the reactant it's in aqueous form, it means it's sort of a solvent. That's why if you can look at the reaction, it's aqueous plus solid, and you still get somewhat that same solution, maybe in a different form, or maybe a property is added. Of course, I'm not into that at this point. I only want you to balance the equation and apply the rules, okay? So S is solid. Okay, let's do that. Oh, wait. Can I just copy that? Because I don't know, I can copy here. Sorry, okay, that's card. Um, let's do that. That's because we will have to solve it so that I have, there you go. I will be applying the steps that were um, given a while ago. Okay, let's do that. So this is our, we said this is a neutral solution, meaning just really follow the steps. So it's neither acidic or basic. Yeah, you cannot find any acid. When it's an acid, you usually see nitrogen in the reaction. And then when it's basic, you would see OH or hydroxide. Okay, so let's start. What was the first step? It says there, okay, I don't have my pointer tool. So then, okay, it says there, separate the whole reaction into two half reactions. So of course, well, you can see from rule of thumb, the first one is copper, and of course it becomes Cu. Okay, wait, let's just do that again. Um, let's make it out better. Okay, okay, let's do that again. I have a very sticky tablet. Okay, so first step, a copper, which is aqueous. We turn it into what? The first half reaction is copper to solid. That's reaction A. The second one, so that's iron or Fe solid. It turns to what? Fe 3 positive Aquarius. So this is our second reaction. Okay, I hope you're getting it. Again, the first step says um, divide or get the two half reactions. So these are our two half reactions. Okay, let me just pause that for a minute. Okay, okay. I know I just paused because I read a text message. Sorry for that. So let's continue. So the first step was doing the two half reactions. And then the next one, it says balance the elements. So just balance the number of elements. So we have one copper here. Wait, where's my pointer? Pointer went missing. So I have one copper here and then one copper there. So no need to multiply coefficients. Likewise for iron, I have one iron and then another iron on the product side. Well, you might be confused. Three positive, it doesn't mean it's there are three iron molecules. It only means that the oxidation number of the reactant is positive 3. So the next, it says there should be oxygen, balance it. So no oxygen in the reaction. Should there be hydrogen? There's no hydrogen in the reaction. So we go to the next one, balance charges. So this, by the way, this is your oxy. This is our reduce. That will be our oxidation. This is our reduction process. Okay, so next is to balance the charge. So let's first have A. So that's Cu positive. Oops, I forgot I didn't include the solution type. Okay. Okay, that's Cu. Sorry, where is that? Okay, this is Aquarius. Oh, page up. Sorry for that. This is Aquarius. And then the reaction is copper solid. Okay, this is positive. This is neutral. It doesn't have any sign. So what do you do? We said that to get rid of the positive, we add an electron, thus creating that. So this part now has a neutral charge and copper here as a neutral charge. We're good with that reaction. Let's go to the second reaction. Iron, which is neutral, but gets a positive 3 oxidation number or charge here. Thus, what do? We have to get rid of the positive oxidation number, the positive charge. This is neutral, so what do? This is where we add the negative. Okay? I hope you're getting that. Let's go back. In this case, a while ago, this is positive, meaning it has a charge. Copper here is neutral, so we have to get rid of the positive by adding a negative, which is the electron. On the second reaction, this is neutral, but the product side has a 3 positive oxidation number or charge. That's why you have to add 3 electrons. Okay. So what's the next step? It says add both reactions. Let's just do it on the next slide. Is it okay if I just take a picture so that I don't have to go back to the slide? Okay, let me just pull up my camera. Just how you do it, guys. So there you go. So let's go to the next slide. So the two half reactions are the ones we were getting were first one, it's Cu and then Aquarius plus E negative Cu solid. right? Don't worry, I get better at this. The second reaction was uh, iron, which is solid, into ferric, 3 positive, which is aqueous, plus the 3 electrons. Okay, now it also says on the steps that you really have to get rid of the electrons later on. That's why you have to use coefficients. You have a 3 here. This has 3 electrons, that has 1. So what do? You actually multiply it by, you multiply this by 3, you multiply this by 1. So our succeeding equations would be 3Cu positive aqueous plus 3 electrons equals Cu, it's also 3. And then just rewrite the bottom one. So this is Fe3 positive aqueous plus 3E negative. Okay, now what's next? On the opposite, on the, yes, on the opposite sides of the arrows, you can actually cancel. So we have a 3 here, we have a 3 here, it's canceled. So you got rid of the electrons. So what were the electrons' objective in the reaction or in the half reaction method? It's actually just really to balance the charges. Okay, so let's see. It says now we're actually on the final step. We add them all up together. So on the reactant side, we have 3 Cu positive plus FeS equals 3 Cu plus Fe3 positive. Okay, as I've said in my previous slides, how do I check? How do we check if what we did was correct? You have to balance the number of elements. Also, the oxidation numbers or the charges. So let's take copper first. Okay, on the reactant and then the product side, let's see. On the copper, sorry, on the reactant side, how many copper do we see? We have 3. There you go. And we also have 3 here. So that's a check. What about iron? Iron, we have 1. How many irons do we have here? We only have 1. Okay, what about for charge? Or, yes, or oxidation number? That's 3 plus. So our charge here is 3 positive because this is neutral. And this is neutral also. Even if this is 3, this is neutral. So the charge here is 0 and this is 3 positive. Thus, this is actually a correct balancing equation. Okay? Okay, so you can always go back. This is a video, so you can always go back and just, click that mouse pointer and go back to that part if you're not getting it. But of course, also you can again remember which is a little vague on your part and just do our discussion boards and then in our chat room. Okay, but I will go back. Okay, let's see. I did not. Okay, so I gave you a neutral solution, and then what I did for the steps was first, my first step was take the two half reactions, copper to this, and then iron to this. And then after that, balance the elements. But of course, there was no much balancing because it's just one copper molecule and one iron molecule. So no need to multiply any side of the equation. And then I said balance the charges. So there you go. Because for the copper side, this is neutral, this is positive, so we added an electron. This is neutral, this is 3 positive, so what did we do? We added 3 electrons. After doing that, we have to get rid of the electrons, or not really get rid, but of course cancel them. If there's a better term, it's actually canceling them. So what we did was multiply coefficients. We have 3 and we have 1. So we multiply 3 here and 1 there, thus getting these two equations. And afterwards, just adding the two equations, okay, on just check the elements on each side of the arrows. So this is on the reactant side, this is on the product side, and eventually to check, you just have to count. So copper has 3,